Okay, good afternoon, everyone. My name is Jeff Davis. I will be talking about PostgreSQL, range types, and Rust. I work for a company called Aster Data, a big data analytics company based in the Bay Area. So if any of you guys are interested in employment opportunities, definitely come talk to me. So first of all, kind of how I'll be going through this is I want to make the case that powerful data types are important. The database and application should have some agreement about what those data types actually are. I think range types is one of those important data types, and I'll show you about that, why I think that's important. Then I'll be talking about a language called Rust and its implementation of range types in that application space and how it works with PostgreSQL range types. I'll throw, first of all, a big thanks to Stephen Fackler. He actually, I think he works for Mozilla. He works on the Rust language, and he did a lot of the work. He wrote essentially the entire Postgres driver, as well as the range type support for that himself. So big thanks to him. The way I like to put it is, quick, describe your business in terms of ints, floats, timestamps, that kind of thing. And, when you put it like that, it's kind of, those timestamps or those data types actually can go quite far in explaining what a business is about. You build a sophisticated schema describing the relationships between them. But when things start to get interesting, then that starts to break down, and you actually want something a little bit more interesting. So I'll give just a couple of examples of other successful data types that I think help make this case. These aren't what the talk is about. But full text search is kind of an obvious case for anyone who's done full text search and started out with the text field and used like queries. How many people have tried that before at one time or another? Yeah, so you do the like with the percent signs and you try to implement a full text solution that way. You quickly run into all kinds of problems. One is performance, obviously, but then beyond that, it's just really not the right data type. When you're talking about kind of an arbitrary keyword search, you're really thinking about a set of words, maybe positions, maybe word stems that make up a document. You're not really concerned with, some parts of it at all, like stop words, the, and so forth. That's really, one example of a data type. A lot of work has gone into that in Postgres. Again, that's not what the talk is about. I'm just making the case that, this is an interesting data type. You can try to build it out of the simple tools, but it ultimately doesn't work out very well. Geospatial is another example of that. PostGIS is an amazing extension to Postgres, and it implements a full geospatial data type useful for all kinds of mapping and other capabilities, doing geospatial analysis and geospatial queries on shapes and everything else. So that's a very important extension in the Postgres ecosystem. And sure, you can try to do that with a bunch of integer columns and try to make up shapes that way, but then try and query on top of that, and you run into so much complexity. It's really unmanageable, not to mention the performance problems. These are a few examples, and I think I'll show a little later why I think range types should be included as a part of that. I also think the database and the application should agree about what the data types are generally. If you're, that very quickly clears up any impedance mismatch between the database and the application if you're getting conversions between the real types you actually care about in the database and the application in a consistent way. So if you constantly have kind of interesting objects in your application, but then you try to serialize them down to ints and text and so forth, then it's understandable that would be called an impedance mismatch, and that you'd run into some complexity and problems converting and problems querying that data consistently and treating it consistently in the database with how the database with how the application might be manipulating that same data. Range types. I'll be jumping into a couple of examples here. But the basic idea, I've given talks on this by itself, but just the quick version of this is that it defines a range of values with a definite beginning and definite end. It could be, the ends could be inclusive or exclusive, and there are a few other details. But the bottom line is, rather than it being, say, a SQL interval type, which might be 2 hours, right? And that defines kind of a duration of time, but it's still essentially a scalar value. This range type actually has a definite beginning and definite end. So you really need 2 bits of information or 2 pieces of information to really understand that range value. This is particularly useful for time ranges, I believe, because of scheduling purposes. So let me try to make a quick demo of this. Excuse me one second. Just resizing the window here. Let's see, hopefully that's big enough to be readable there. So you could create a table, for instance. Well, to start off, you could just select a simple range by doing something like this, int for range from 1 to 10. Okay. So the first thing I'd like to point out is 1 to 10. The first, if you can't see it, is a square bracket. And the ending bracket, that's a parenthesis or a round brace. So this represents the range beginning at 1 and ending at 10, including the value 1, but excluding the value 10. So because these are integers, that's a total of 9 values. You can do a simple query on this, such as this is the containment operator, at sign greater than, and does it contain the value 2? And we see that that's true. You can also do the overlaps operator, which is double ampersand. And this is also true because these 2 ranges overlap. So we can see that we're no longer treating the endpoints specially. We're actually treating them like more like sets or mathematical intervals, to be more precise. This simplifies a number of queries. To give an example of a query that you might try writing to implement this with just integers. So if you were to try to do overlaps, you'd end up with something like select, some kind of, let's say you have some variable, start, is less than, So if you'd imagine writing queries like this, I2, and then a bunch of, and, or, and then, you'd have in there maybe mixed in if you're using null for the unbounded ranges. If you're using null, then you'd end up with a bunch of, is not null kind of predicates. It would actually end up being quite a long query. Not going to try writing it now just because it's complex enough that I'm sure to make a mistake anyway. But with ranges, these are quite simple to write. Let's say, for instance, I have an unbounded range here. So that's essentially 4 to infinity is the semantics of that, and that returns true. So you don't have to think necessarily about all these edge cases. Should I use greater than or equal to versus just greater than here? How many different versions of comparing the first and the last bound do you need to actually specify overlaps? It gets a little bit complicated. So range types just simplify things greatly, and that's the idea behind them. Does anyone have questions at this point?
Yeah, the fact that the open-close business, is there not a way of controlling that? Whether you get started in it?
Yeah, there is a way of controlling that. You can. Oops. So let's say it can be a little bit awkward, but let's say you specify them using the same notation of the square brace and open brace. So let's say we wanted to invert it. We can add a third optional parameter to specify open, say, and then it's the same. So what happened here is, remember, we're dealing with values here. So this is logically the range from 1 to 10, excluding both 1 and 10. But that is equivalent value to the one displayed on the screen. That's because we kind of normalize it for the output representation. We don't want to distinguish between two equivalent values, which is a confusing thing to do. You can distinguish between the output representations, but you don't want to distinguish between two equal values. And 1 to 10 exclusive is equal to 2 to 10 inclusive exclusive. So you can specify things kind of in that way, and it works very seamlessly with the rest. So when you use overlaps, contains, those kinds of range operators, then everything just works, and you don't have to worry about lots of special cases to deal with. And that's really one of the main things that I'm trying to do here is eliminate special cases. Trying to simplify the queries and simplify the thinking behind using ranges rather than trying to use a complex series of start and end bounds for the ranges individually. So any more questions?
Is there a way to control the output format if you wanted to see them all as close?
Right now there's not. They're probably a few different ways to do that. I mean, you could certainly do that by deconstructing the range, sort of like, and controlling the output format as you'd like to see. But right now, there's use floats. There are ranges can be extended. So there's integer ranges, timestamp ranges, timestamp time zone ranges, date ranges, and numeric ranges. In the kind of out of the box. But let's say, one thing we could do is we can define new range types. Create type float range as that enough? Okay. Okay. So as range subtype equals. Okay. Oh, I know why. So now we have float ranges. So we have float range 1.4 to 7.9. And then we can verify that it's a float by doing something like that and see what happens. If that were numeric, it would probably show all that precision.
But now put comma, 2 square brackets, open close square brackets, and we haven't seen it ever not put a.
Oh yeah, so there's some. So I'll show you. That's a good point. So let's say we do that with the open syntax where it's exclusive. Oops. Okay, I need to. So here it stays open. And the reason for that is because there's not a very useful definition of, kind of one tiny bit in a range, one tiny increment of a range to normalize it. So although the float type technically is, a discrete type, it's got a, finite number of bits in the representation. And so therefore there will always be that one next value in theory. That's not very useful from a reasoning standpoint in most situations. So you could, if you were very nitpicky about it, you could try to create, a range, 2 ranges that were actually equal in the sense that they represented the same set of values, but might not be seen that way by the system because we don't use that kind of float increment notion. So, we treat floats essentially like numerics where there is no one single next value.
Personally, I would argue that the way you represent integers is not as good. I would rather see it in round bracket for the integers, round bracket 1 rather than square bracket 2.
I mean, sorry. So you mean just the convention that of the inclusive and then exclusive? What convention are you accustomed to?
No, well, basically in your previous example with the integers, I would use round bracket 1 rather than square bracket 2.
Okay, but you mean even if the range were specified as say square bracket 2 comma 10 round bracket? Okay. Yeah. Oh, okay. I mean, the reasoning behind that is that the values are equal and should be treated that way in all contexts by the database system. So that was my reasoning for that. I mean, it was okay. I'll kind of move on a little bit. We're getting into a few of the details about ranges, and that's not entirely what the presentation is about. So I'd like to make sure I introduce some of the other concepts I'd like to talk about. But I think we all have a feel for what the range types are trying to accomplish and what they're trying to simplify. And they accomplish several things, including performance and just the understandability of the queries. So let me come back here. Okay, so this is kind of what range types are really adding. So you use beginning and end columns, and then you can end up with these long, messy queries trying to specify simple things like overlaps, and that turns into a problem. It's inconvenient, it's error prone, it's awkward, and there's all kinds of mistakes you can make. No indexing support for if you're just specifying as individual integers like that. The best you have are ordinary B-tree indexes on those integer columns, and you're not going to get the performance you expect from that kind of from the kind of queries you actually want to run, which are the overlaps, intersection, that kind of thing. And then just it, handles some of the details like empty ranges and so forth. Yes?
Actually, there's a worse thing there on that.
Oh.
So, on that first bit, it's not just it makes the query longer, every query needs to be aware of which edges you're going to be using. So in this, by using the range type, you can control it from the data, whether you're getting whether you're inclusive or exclusive. It doesn't have to be part of explicitly handled by the query.
Right, yeah. So if you use the beginning and end column, I think the point was that you have to pay very close attention to the convention that you've developed. So for instance, it becomes hard to use sometimes the open-close notation or sometimes the closed-open notation, something like that.
If
Yeah.
you're going to have two behaviors in your system, you have to have two separate queries.
Right,
If
exactly.
one is inclusive and one is exclusive, you have to have two queries. Whereas with the range type, the query doesn't have to be aware of it. The data is aware of it.
Right, yeah. Yeah, I think that's a good point. And then one killer feature for range types is exclusion constraints. So the idea here is a schedule conflict is a very simple notion just in everyday conversation. Everyone knows what a schedule conflict is. But to actually enforce non-overlapping schedules in a database system, any database system other than Postgres has major problems with this. For example, you could try, if you actually try to avoid the race conditions, then you could end up locking the entire table or resorting to some other very strange, series of procedural code or locking pattern or something like that. But ultimately, it's not going to perform very well. It's going to be very complicated. Or you can try a simple strategy of maybe locking the whole table, or you could, essentially, break it into these larger values than you'd really like to deal with to make it kind of, to chunk it into time slots, which is what a lot of people end up doing. But it's really awkward, and it causes a lot of problems. But I'll show how we can overcome that very easily using Postgres with a declarative constraint that performs well using index lookups with similar performance characteristics to it, say, unique constraint. And we get kind of the best of all worlds. So let me give an example of that. Okay. So this is TSTZ means timestamp with time zone range. So it's a range of timestamp with time zone. And then, okay, we'd ordinarily have like maybe a user do something like that. Okay. Yeah, who has not made that mistake? Okay, so what we could do is we could first let's add the exclusion constraint. Okay, so one minor detail: we actually need to make use of the btree gist extension for this example to work. So because of the create extension syntax, that makes it very easy. Stephen?
When are we going to stop that? Aren't we going to just put btree gist in?
I think I had raised that at one point. It's a possibility. So
it's just, a lot of people
yeah.
don't, they go to use range types and they realize it needs a gist index, and then they're like, but wait, I need more than just my one column. Put the range,
Yeah, exactly. Yeah, so that's
that.
yeah, it's a problem essentially everyone runs into. So to make full use of this, you really need the btree gist extension. It's been there for a while. It works pretty well. Not too much to be concerned about there. So hopefully that could end up in core eventually, or there could be an easier way to to include it. Then let's alter table, add exclude for exclusion constraints. Using gist, this is the index access method that's going to help us enforce this constraint in a performant way. Room with equality and duration with overlaps. Oh. Yeah. Thank you. So alter table reservation. Okay, there we go. So we have this exclude using gist. Room with equals means, if the room is the same. Duration with overlaps means if the durations overlap, then we have a conflict. So we're describing the conflict condition here using the syntax is a little bit funny, but we're describing the conditions under which two tuples conflict. They conflict if the room is the same and the duration overlaps. And that's how to read that. So, let's go ahead and, insert some reservations into reservation room. So 1, 2, 3 reserves room 45A for let's do Oh, cool. We even have decent errors for the parse errors in these values. So, okay, so we inserted 1 for essentially right now. So reserving my own speaking time. And then let's say, user 423 comes in, reserves 45A for 1320, let's say, to 1445. Then we get an error. So we can go through a bunch of permutations here if we had more time. But the bottom line is that it prevents these overlapping reservations. It does it declaratively, meaning that if you have tuples in there already, you add the exclusion constraint later, it's going to fail adding the constraint, just like a unique check would fail if you added it after you have duplicate values in the table. It works concurrently. Unless there's a real conflict, one transaction won't actually sit there. Or I should say, unless there's a real potential conflict of things that actually overlap or actually meet this conflict condition, then the transactions won't wait on each other. They'll proceed. So we have kind of the best of all worlds here in terms of enforcing this kind of a constraint. So that's really the value of combining range types with exclusion constraints to enforce these kinds of things. And there's actually some pretty interesting other things that you can do related to this. So I encourage you to experiment a little bit. I think I wrote a couple blog posts a while ago when these features were introduced. So I encourage people to check that out. There's other people who wrote blog posts as well. But questions at this point?
Yeah, I'm just wondering, is there any prospect of having an index type which will both support
Oh, you mean, so I think, so we're using GIST, which I think you're saying doesn't support index-only scans. Is that correct? I actually don't know off the top of my head whether it does or not, but if you say it doesn't, I don't think there's a fundamental reason why GIST wouldn't work with index-only scans. So I think that that's just a matter of making sure we get that support, in. I think the intention is index-only scans should work with all index types.
If you're lucky, 9.5 will have that, because there's a Google Summer of Code working on just that.
Okay.
Doing Xcode scans for just, she's just begun, so I don't know if it's going to make it, but I hope so.
Okay. Yeah. So great. So that is just a matter of code then, or something? Okay. Great.
I mean, it's not, you can't do it for all just indexes, but for those that have enough information in the values that it indexes, you can, like I think it would work.
Right. Yeah. That the index, of course, in order to do an index-only scan, you need to be able to reconstruct the entire value properly, and so the methods for range types make that possible to construct the whole value. So that shouldn't be too much of a problem, assuming we, after we add all of this support to these other index access methods. Okay, so let's jump back to presentation. Oh, Morty, what's going on? Oh. Okay, so we got that. Okay. Okay, so Rust. First of all, who here hopefully knew that Rust was a programming language written by Mozilla? Okay. So this is kind of an interesting language. It's got a native Postgres driver. Okay, so basically, range types, Rust offers a few advantages. It's a systems-oriented programming language, so it's a little bit more verbose, but it's very safe. It prevents any kind of the ordinary kinds of memory errors like null pointer exceptions, any kind of the seg faults, those types of things are eliminated by Rust's type system. Yet it offers very good control over memory and does not require the use of a garbage collector. So it's a suitable systems programming language. It's still in development by Mozilla, but the idea is that bringing safety to the kinds of applications people are writing that have high performance requirements, especially requirements about controlling the memory. Many cases right now, C and C++ are kind of the only games in town. If you want to have good control over memory, aside from a few other languages that are used in certain verticals maybe, but for the most part, C and C++ are the ones out there. So Rust offers an alternative to those that are safe from the kinds of memory errors that are so common in those languages. And it's, because it's a systems programming language, it's also fairly fast. The Rust Postgres driver is, again, written by Stephen Fackler. It's a native driver, so it doesn't require the use of libpq. And that's kind of nice because it's a little bit more flexible and doesn't have as many dependencies. The reason I'm talking about Rust, it's a very new language. It's not even solidified yet. But the reason I'm talking about it is because they're doing a lot of interesting things, and they're the first ones to support range types. And I think that the way it was done was very nice and a good illustration of both the of all of the things I'm talking about here, which is the language making good use of the database, as well as having coherent notions of the same data types. so that way, the application is not using a totally different set of data types from the database. And I think some of the language features add to that. A lot of it is simply just because this is the first implementation of range types in application space that can talk with Postgres. And there's other cool things going on. I think they're developing. It's written at Mozilla, so of course they're developing a browser engine in this language called Servo. And then other people are doing some kind of cool things. There's like tiny operating system projects going on that are mostly just for learning now, but there's a cool blog post series by somebody named Julia Evans. Anyway, this isn't about a rundown of the features, but just this is why I chose it. And it's largely because it seems to be a good fit for range types. It has the generic type system is probably the big one, because that's what allows, just like we defined a new range type over floats in 5 seconds, during the demo. That also, that generics power also needs to be present in the programming language to really get the full benefit of range types from the database, because in Postgres it's a generic type, a generic container, and so the fact that the programming language can support that too is important to get the full benefit. I'm going to kind of throw some code up. I know since most of you, almost everyone has not really heard of Rust, and very few people are really writing in it. But I'll show kind of what I was hacking on. This is not a real project. I'm not launching this as an open source project, but this is something I was working on. So let me get my mouse back. Okay, so. Is that readable? Uh-oh. That is not very readable. Okay, good. Well, okay, good thing those are just the comments. So anyway, okay. So I'll kind of ignore some of the boilerplate, but this is basically uses an HTTP library to act as a server. And then we'll have a kind of a simple web page interaction here. Very rough, of course. Basically I've got this get content method, and it's just, generating some content dynamically and then outputting it. You can see it's a little bit more verbose to satisfy the type system than you might be accustomed to in something like Python. Hopefully they work out some, good conventions to make that, not so bad. Anyway, we're just, connecting to Postgres. And then, appending some simple HTML and a string. And then here's where we start to do the database interaction. So what we're going to do here is we're going to select some integer ranges from a table called X. And then just kind of iterate through those. The interesting part, though, is we're going to have another query in the application language here, which is itself a range. And we're going to print the range from the database in green if it does not overlap with this range. We're going to print it in red if it does overlap, indicating a potential conflict. Of course, a real application would be doing something more interesting, but you can kind of extrapolate from here. So one of the other nice things about Rust is that it's got a macro system, and that was another reason it kind of fit in with the whole ideal that I'm describing here. So it actually allows us to have syntax like this. This is not really just a function call. We've got actually matching with the Postgres behavior of the bound inclusiveness, the square bracket and the round bracket here indicating inclusive and exclusive respectively. And then, inside we've got these values here, and it uses that to construct the range. So this is from 50 to 60. Being a systems programming language, it's got these kind of literals are tagged. For instance, for an integer, you say I32 or some kind of native integer size or whatever you want. But here I'm just trying to keep it simple. They're an int4 range. We want it to be an int4 range in the application. That means we're using I32. So it's unambiguous. So we have that kind of query there, and here's kind of the loop. So for every row in the result, we start off with it as a green color, and then we actually replace the color with red if the intersection is empty, which is another way of saying that there's an overlap. And then we just output this format string, including both the color and the value. And then we're done. So there's actually something else very interesting, I think, going on here. But I'll get back to that in a second. Okay, so now let's... first, okay. So let's build it. Few imports that I'm not using, so I get warned about that. Takes a while to compile. They'll hopefully fix that when the language is more finished. And then, now I need to actually go back here. I need a browser, so. Okay, it doesn't fit. A second, I'm trying to resize this window again. Okay, so a bunch of int4 ranges there. So we can see I'm reloading it, and so 10 to 20 does not overlap with 50 to 60. 10 to 200 does. 30 to 51 does, but 30 to 49 does not. And if we go back to the Postgres session, we can find table X, and we can insert into X values. Okay, I'm just about out of time here, so I'm going to try and make this quick. int4 range. Somebody have a range they'd like me to insert? 1050. 1050? Yeah. Okay, so first let's decide whether this should overlap or not, and then we'll see based on the red-green color whether it does. So what should the inclusivity and exclusivity of this 1050 range be? What would we expect that to be? Yeah, exactly. So it will include 10, but exclude 50. And then we can look back at the Rust code, and we see that this includes 50, excludes 60. So since this one excludes 60, or sorry, since this one includes 50, and the other one excludes 50 that we just inserted, we would expect this to appear in green. Is there a question back there? Oh, okay. So let's. And it's green. Let me. I'll just wrap up and ask for any questions here in a second. But one other thing I'd like to point out that I think is quite interesting about this is the way Rust's type system works is see that we just declared this value to be a range of int32 in Rust equals the first value in that row coming from the database. Now what's interesting is this is able to choose what conversion function to apply in order to get the int4 range out of the database and into Rust based on this line. So it's actually based on the type of the value you're reading it into. In other words, kind of the return value of the expression. It's able to infer the, of course, the type that this should be, but beyond that, it's able to actually use that to choose the conversion function. So I think that's a pretty cool approach. I think a lot of other languages do a lot of kind of messing around with OIDs and then forcing the output type and trying to include the fixed constant OIDs of the types they know about. And this makes it more extensible because as you add, say, new range types and new conversion functions, then it works more seamlessly. You don't need to find the OID and hard code it someplace necessarily. For good error checking, you might want to, but that becomes optional. So this, I think, has a better chance of working well with user-defined data types and then user-defined ranges on top of those user-defined data types, and really seeing the full extensibility that Postgres has to offer. So I just see a lot of great interaction between what Rust can do with types, what it can do on the database side, how Postgres works and Postgres' strengths, and how they all fit together very well. So I think this is kind of a great example. I think other languages can do a lot of these things too. But like I said, of course, Rust is the first one to support range types natively. So from here, I'll just take questions.
Isn't there an easy way to explode a range back into rows?
A range back into...
Like if you wanted to return...
Oh, I see what you mean. No, we don't have a way to do that. This also supports these kind of continuous ranges of numeric where it would be, kind of essentially, it would be essentially infinite sets or something. So it might be an interesting area to explore, but, right now the range types don't do anything like that.
Is there a use case where you want that?
Potentially. Trying to iterate over a list of days or something to figure out what a value was for each day between point A and point B.
You should be able to have a generate series.
Yeah, you can do
Take
something like that.
generate series, pass in the first element, and then the number of entries that you want to generate. So that's a small matter of programming there, but that's not very big. There are operators, there's functions to let you get what is the start of the range, what is the end of the range. So that's enough information for you to pass in to generate series.
One use case for that is if you want to explode it or unpack it, then you do union or remove something from it and then pack it back in ranges to get those ranges. Just pick up one value from the middle and get two ranges that exclude that. We don't have those operators either.
Say again?
But we don't have support for any of that.
Right. Yeah. There's quite a few interesting ways of manipulating and operators laid out in a book that I believe Heikki may have read as well. That it's called Temporal Data and the Relational Model by C.J. Date and Nicholas Lorenzos, or Date and Lorenzos, and I think Q. Darwin as well. But, anyway, so that another question over here.
Another use case would be a custom type of INET, a range of internet types. It would be nice to have all the valid IP addresses in that range.
Yeah.
And as a custom type internet
Right.
range, INETs are really, really useful as a complement to the site indentation.
Right. Yeah. I think that that's been brought up. So Postgres INET data type supports the net mask, so it's not a totally ordered type itself. So it's like just an awkwardness. I believe you're right, and I agree, but it's an awkwardness because we need to define a new totally ordered type that doesn't support the net mask in order to have that.
As a sort of a lot to follow, an INET range is really, really handy.
Okay.
Pretty simple to implement ranges.
Okay. Yeah. I mean, I agree with that. Yeah.
All those rest on those connection back to this web.
Oh yeah, if you create a range here, you can just do an insert statement, and it supports kind of a two-SQL trait that allows it to convert back and go right into Postgres. So you don't need to do any special conversion to get the range back into Postgres after you've manipulated it in Rust.
Are negative ranges supported? Is it just normalize it back to the regular?
You mean if the lower bound is higher than the upper bound? That will generate an error. I've gotten that request several times. Somebody was trying to describe a use case to me. I don't think I fully understood the use case for that. But for what?
That would be negative and positive. So if you're just kind of just throwing together something that's automatically inserting values for geoinformatics, for example.
Oh, okay.
You have negative 80.
You could work, if you just wanted it to flip it, that would be fairly easy to do programmatically. It's not supported now. We decided, yeah. The idea was that if somebody wanted to do something like that, it was most likely an error, and it's better to throw an error when it's a likely case, and then support the other case, if you need to with procedural code. I think that was the thinking at the time. But if I understand better some of the use cases out there for it, I'd reconsider. Say again, sorry, I can't hear well. Yeah, you could have, if both of them are exclusive, you just end up with a singleton range in that case, and it's a range consisting of exactly one value. Yeah.
Not the cheerleader bit for the internet ranges. If you put them in an array and use the any operator, it's a really fast way to say, hey, is this IP in any of these ranges here?
Oh.
So combining those two was, and I couldn't find any other language or any other way to do that. That was very, very effective.
Oh, okay. That's a pretty powerful use case.
Does Rust have the similar concept of empty ranges?
Yes, it does. It's got empty ranges as well. So yeah, I guess you guys, if you were. So, don't know if I tested this one, but I guess in the spirit of a live demo, we'll see what happens. And an empty range doesn't interact with anything, so this would be the expected result.
Do you know if the Rust people came up with the semantics of these things themselves?
Well, they looked at Postgres. I filed a ticket at the GitHub repository for the Rust Postgres project, and Stephen Fackler just took an interest and looked into Postgres. He was already, fairly comfortable, I think, at this point with the Postgres documentation because he had actually implemented a native driver. So I imagine, he just looked at a lot of the documentation, and I gave some feedback, but he, for the most part, just got this stuff, very close to the Postgres semantics right away. And so, that's the point that I'm trying to make, is that the semantics should match rather than having them inconsistent. Okay, well, thank you, everyone.